The topic is movement of forces. It is also called torque or movement, right? So these slides are designed specially for the students of O level who are going to appear in IGCSE GCE or EdXL. But the other students, for example, students of matric, they can also get benefit from these slides. So, what is movement? Movement is actually turning effect of a force, right? If we apply a force on a thing and it turns, right, turns around a hinge, for example a door, right, if it turns around a hinge, that turning effect is called the movement or the torque, right? The force needed to pull a door open depends where it is applied. If it is applied away from the hinge, you can experience it at your homes. If you will open the door of your house near the hinge, it will be difficult to open, right? So, if you apply a force near the hinge, the turning effect will be less. But if you apply a force away from the hinge, as in the door which is on the left side, the man is applying the force away from the hinge, so there will be more turning effect. So it means there are two things that will determine the movement. The two factors, one is the magnitude of the pull, that is with how much force you are pulling the door. The second thing is the perpendicular distance from the force to the pivot. Again repeat, this is a perpendicular distance, right, from the pivot to the point of application of force. Okay, so movement is the product of force and the perpendicular distance. Perpendicular distance is also called movement arm. So force into movement arm is the movement. Mathematically, we will write it m is equal to F into D. F is the force and D is the movement arm, which is the perpendicular distance. The units, we can derive the unit from the formula. The units for force are Newton. The units for the distance are meter. So the units of movement are Newton meter. It's a vector quantity because it will turn either clockwise or anti-clockwise. So it has a magnitude as well as direction. So movement is a vector quantity. Okay. So here we have some relations between force and distance, right? Uh, if keeping the movement constant, force and distance are inversely proportional to each other. It means that more the force, larger the force, lesser will be the distance. Or you can say it, if the force is applied at a lesser distance from the pivot, large amount of force have to be applied. If the force is applied at a larger distance from the pivot, then the force will be small. So force and distance have an inverse relation. You can see in the diagram, smaller the radius, larger will be the force. Larger the radius, smaller will be the force to apply the same amount of movement. And the last thing is that the movement or the turning effect will be zero if we apply the force at the pivot. You can experiment it at your homes, that if you open the door from the pivot, the door will not rotate. There will be no turning effect if the force is applied at the pivot. The reason is that at the pivot the perpendicular distance is zero, right? As the perpendicular distance is zero, so there is no movement, because movement is a product of force and perpendicular distance. So if the perpendicular distance is zero, there will be no movement. Okay, then let's talk about the direction of the movement. The movement can be clockwise or anti-clockwise. Let's talk about the picture in which we have this clock on the right. There are different types of forces. This 10 Newton force is applying a movement of clock in the anti-clockwise direction. Similarly, the 15 Newton, 50 Newton, all these forces they are applying a movement in anti-clockwise direction. This 25 Newton force, which is in upward direction, this is also applying a movement in anti-clockwise direction. Right? So let's move on. Principle of movements. What are the principle? The first principle is that when the body is at rest, sum of the clockwise movement should be equal to sum of anti-clockwise movement. It means the clockwise movements should be equal to anti-clockwise movement to keep the body at rest. For example, here you can see there are two boys, both have different weights. To keep this seesaw at rest, the movements of these two persons should be equal. So let's see it mathematically. For example, the man in the blue shorts, the text for that man is also written in blue. So he has a weight of 1000 and a perpendicular distance of 1 meter. So 1000 multiplied by 1 will give us a movement of 1000 Newton meter. And this boy in the green shirt has a weight of 500 Newton but sitting at a distance of 2 meters from the pivot. So his movement will also be 1000 Newton meter. As both the movements, now you can see the boy in the blue shirts, he is applying a movement in clockwise direction. The boy in the green shirt, he is applying a movement in the counterclockwise or anti-clockwise direction. The direction of the movement is opposite, but the magnitude is same, so they will cancel each other and the lever or the seesaw will remain at rest. Balanced and unbalanced movement. So this is a balanced movement, right? This is an example of a balanced movement. This is an example of an unbalanced movement. This is a real life example of an unbalanced movement. So here we have some daily life examples of movement. For example, opening the nut of a car with the help of a spanner. So why is he using such a long spanner? We read it a few slides back that more the distance, lesser is the force applied. Right? So that is why he has increased the distance so that a less amount of force should be applied. So this is also an example of torque or movement, turning your tires with the help of your steerings and twisting the clothes and opening the taps. Merry-go-round is also an example of movement, and opening the nuts from with the help of spanners and opening the doors. These are all the examples of movements. So conditions of, what are the conditions of equilibrium? There are two conditions. First, talk about what is equilibrium. Equilibrium if the body is at rest, right, or it moves with uniform velocity, it is said to be in equilibrium, right? So the conditions of equilibrium are that sum of all the forces acting on a body is zero to keep the body at rest. Let me repeat it. To keep the body at rest, the first condition is that sum of all the forces acting on it is zero. For example, in this figure, to keep them at rest, the sum of the rightward force should be equal to sum of the leftward force, right? So it means that 300 should be equal to 300 to keep them at rest. That was the first condition, sum of all the forces acting on a body. So if we make sum of these two, 300 minus 300, so that will be equal to 0. Sum of these forces should be 0. The second condition for equilibrium is that the clockwise movement should be equal to anti-clockwise movement, or we can also say it like this, that the sum of clockwise and anti-clockwise movement should be equal to 0. We can say it in two ways. First way is that clockwise movement should be equal to anti-clockwise movement, or sum of clockwise and anti-clockwise movement should be equal to 0. Like in this example, 1000 minus 1000 will be equal to 0. So mathematically we can write sum of all the forces equals to 0, sum of all the moments equal to 0. So these are the two conditions of equilibrium. If the body is at rest or moving with uniform velocity, it should meet these two conditions. It must meet these two conditions to be in equilibrium. Okay, let's look at this example. In this example, you have to find the moment. So force is 10 Newton and a distance is 0.5 meter. So 10 into 0.5 will be 5 Newton meter will be the moment. So you can solve these examples at home. Okay, let's move to the next topic, which is center of gravity. The weight of an object acts downwards towards the ground. We know that when the object is pivoted near its edges, its weight causes a turning effect about the pivot. However, if you place a pivot at a particular position, its weight has no turning effect. You can do this experiment at home by balancing a pencil or anything uh, straight. For example, you can balance a rod on your finger, and you can observe that when you will place the finger near the edges, the pencil will or the rod will rotate. It will have a turning effect. But if you will place your finger exactly in the center of the pencil, right, or exactly in the center of the rod, there will be no turning effect. That point, right, that point where the turning effect is zero or the moment is zero, that point is called the center of gravity of the object, right? Or that point will be the pivot of the object or the center of gravity of the object. And we know that if the force is applied on the pivot, there is no turning effect. Center of gravity of regular shaped object is very easy to calculate. For example, in line in A or a rod in B, the center of gravity will be exactly the geometrical center of these lines or the rod. Similarly, in a circle, the center will be the center point or half of the diameter, right? And in a triangle, you can find the center by taking the angle bisectors, or in a rectangle by making the diagonals. So regularly shaped objects, for the regular shaped objects, the center of gravity is very easy to find. We can find the center of gravity of geometrical will be at their geometrical centers. Okay, for a irregular shape object, for example, this lamina, which is an irregularly shaped object, you can find the center of gravity. Uh, for that, you have to make 3 holes in this lamina, and then suspend the lamina freely from a pin, and then hang a plumb line from the pin in front of lamina. When the plumb line is steady, trace a line. These dotted lines which are on this lamina, these are the traced lines. When the plumb line is steady, trace a line along plumb line on the lamina. Repeat this process for all these holes. With the point of intersection of all these 3 lines is called the center, or it will be the center of gravity of this irregularly shaped object. So this is how we find the center of gravity of irregularly shaped objects. The next topic is stability. For example, here we have a book which have 6 faces. 2 of its faces are broad and the 4 faces are narrow. And the book is standing on one of its narrow faces, right? So suppose it's upright on its narrow face and we give it a slight push, the book will topple, right? If we give it a slight push, it will topple. However, if we lay the book flat on its broad faces, any one of its 2 broad faces, and give it a slight push, it will not topple, right? It's a common observation. The stability of the object is measure of its ability to return back to its original position after it is slightly displaced, right? So the book is not stable when it is on its narrow faces, it is stable when it's on its broad faces. So these are the three types of stability. One is stable, unstable, and neutral equilibrium. The cone in the first cone is stable. The second cone is unstable because if it's given a slight push, it will topple and will not come back to its original position, the position shown in the picture. And the neutral equilibrium, it will have no effect, right? Okay, here we have a cone. You can see if the cone is slightly tilted, the center of gravity rises, and the pivot is on the extreme right of the cone. You can observe from the second figure that the movement which this weight of the cone is applying, the weight is in blue color. The movement which this weight of the cone is applying about the pivot is in counterclockwise direction. So due to that movement, this cone will return back to its original position, right? Whereas in this case, due the moment which this weight will apply will be in clockwise direction, and you can clearly see that due to the movement of this weight, the cone will topple, right? So it means when the base was large, the body was more stable as compared to when the base of the cone is small. So we made some conclusions from these previous slides, from the example of book and from the example of cone, that an object can be made more stable if its center of gravity is made lowered. For example, in the case of the book, we made this when on its broader face, its center of gravity was much more lower, so it is much more stable in that state. And if its base area is made larger, for example, in the case of the cone, when the base area was made larger, it became more stable. So we have some examples in which we will make the base area larger and will lower the center of gravity to make the objects stable. For example, a surfer surfing on an ocean wave need to stabilize himself by bending his knees and lowering his center of gravity. By bending his knees, he lowers his center of gravity, and by spreading his legs, he has large base area. So these are the two methods to increase the stability of any object. So this surfer is wise enough to adopt all these two methods, right? Formula 1 cars has a broader base and lower center of gravity as compared to the other vehicles to make it more stable on the road. So you can think about some more daily life examples in which we can become more stable by adopting these two rules. Okay, for example, here we have a balancing toy. How this balancing toy balance itself on a simple point, right? This is the Freebird diagram. You can see in the first diagram, in the A, where it is at rest position, right? We can read the explain why the toy returned back to its original position after being slightly displaced. In the B position, it is displaced slightly, right? So you can see that the center of gravity of the point through which the weight of the body appears to act, when the toy is at rest in A diagram A, the center of gravity is directly below the pivot. Hence there is no movement, because the center of gravity is exactly, the weight was exactly below the point of pivot, so there is no movement at the rest position. But when it is slightly displaced, the center of gravity shifts towards right. Now you can see in the picture B that due to this weight there will be a clockwise movement about the pivot. So it will return back to clockwise direction, and due to its momentum it will not stop at the rest position but it will move towards the left. And again when it will go towards left it will have a counterclockwise movement which will bring it back to right. Then it will again have a clockwise movement which will take it to left. So this is how it keeps on moving left and right. Okay, that is the end of the chapter. In this chapter, we have covered the topics of force, resultant of forces. We have covered the topics of Newton's first law, second law, third law, and friction, effects of friction, equilibrium, conditions of equilibrium. Then we have covered the topics of movement. We have covered the topics of center of gravity, Hooke's law, deformation, and deformation due to force, and we have also covered the topic of stability. The notes for this chapter are given in the description.